Warning: tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Hey y'all! Well, another 300B build, and while this is using the same schematic and all that kind of stuff on our other builds, it's going to be a different layout. And this time, the customer wanted to supply their own chassis and then send me this to finish it up. And so I had another viewer that has a CNC machine. We worked out the layout on this top and bottom plate, and then I got it black anodized, which I think looks really nice, and we're going with the silver trim and full ISO iron, the choke, the power transformer, everything. And I'm going to go over in the next couple of videos about how we're laying things out, some of the challenges of having this wood surround, and we'll get inside and show you the challenges of this layout and how I'm going to be laying all this stuff out. Okay, we're going to go over the driver tube circuit, and every time I build one of these, they're a little different, and this one is no exception, but it's the same circuit, this cascode we've been using. We've got the negative coming here, then we have another wire back behind here, and you can see it plainly here. It goes from this terminal to this terminal, and the same thing over here comes from this terminal to this terminal. And I left this capacitor off so I could show you where the interconnects are without it blocking your view. So we'll kind of go over everything with this 6S and 7 here. So these are the heaters. That's pins 7 and 8. Pin 1 is the grid of the lower triode, and this is where our signal is going to come into the amplifier. So we have our grid leak resistor, 1 meg, that goes from the grid to the ground. This is the ground terminal. So this is the cathode, this pin here, number 3, and it comes down here to this terminal here. We're going to put our LED from here to here. It's going to be the last piece I put in because it's pretty heat sensitive, and you want to have as little heat on it as possible, so it goes in last. So this is the plate of the lower triode, and it's connected directly to the cathode of the upper triode. And this is a piece of AST pure silver wire. Then we have the plate of the upper triode. It comes to this terminal right here. This is where the signal to the output tube is going to connect. And let me scoot this over just a little bit. And the coupling capacitor is going to go between here and there. And the other coupling capacitor is going to go from here to here, which is the grid of the output tube. And here's our grid stopper going to the grid of the output tube on both those. So let me scoot this back down. So the B plus is going to connect right here and right here. And this is our 4.7K dropping resistor that goes across here and there. Got a 33F 500 volt cap from this terminal to here and here and here. And this isolates the front end tube from the power supply to the output tube. That's the purpose of this. Some people use one cap for both channels. I like separating the channels so there's less crosstalk between them. So each channel has its own filtering cap for the B plus on the front end tube. This is our plate load resistor that goes from this terminal to this terminal, and it's a 47K. And the final piece, which I haven't installed on this tube yet, is the voltage divider for the grid of the upper triode. And you can see here we've got a 680K resistor that goes from this B plus point on the driver tube to the grid of the upper triode, which would be from here to here. And then one of the things I did on this amp to make this a little easier, there's a 200K resistor that goes from here to here, and then there's also a 0.22 UF 200 volt film cap that goes from here to here. And so to make this a little easier to assemble, I put the 200K resistor like that and soldered it between the two leads of the cap, and then bent these up so they can hook onto the terminals. And then when I get ready to solder this in, it will just go like that and hook on those two terminals, and it'll be like that. So you get the resistor and the cap as kind of a combo deal. It just was a little easier to assemble that way, and there's less chance of the resistor leads shorting out against something. So I thought that was kind of a neat way of doing this, and I'll be doing that in the future like that. And you can see you just twist the leads of the resistor around and solder them on. So then you get a resistor cap combo that you install. So anyway, get this other resistor put in, and then I can come back and put my LED from this terminal to here and this terminal to here, which will go, again, we got like a 200 ohm resistor in series with the LED that goes to ground. And that's going to have the front end wired up. I powered up the amp earlier, and we've got nice voltages on the 300B tube, and I like getting the power tubes all wired up like they are here so that I can power these up and then come in and check. This would be the cathode voltage, and then you check the plate voltage on this green wire, and same thing over here. And we've got about 460 volts on the plate, and we've got 72 volts on the cathode, which means we got 32 watts across the tube, which is running fairly hot, but it should make really good power with these transformers. And it's definitely, I wouldn't say hot. They're running at about 90%, which is kind of normal for a single-ended amp. If you're okay with a little less power, instead of using this 880 ohm resistor that I used, you could use a 1K, which is kind of maybe a more normal resistor value for a 300B amp. But I like running my amps hot. They usually sound better. And yeah, we'll see how this turns out. So the other thing that I got installed since the last episode was I got the meter installed, and I got the ground wire hooked up, which comes over here. This is the same ground point, and this is the ground wire that goes over to the front end that I was just showing you. You can see it comes to that terminal, and it comes across here, and this is a ground, and then this wire here goes up to our star ground point in the back of the amp. So we got the meter grounded. We're going to have a DP-DT switch here that'll switch between the cathodes of the two tubes and also have a center off position. And it'll come up here to the positive on this. And then those wires are going to come across here, and one of them's going to connect here, and then one of them's going to connect here. And it'll read the voltage on the cathodes just to let you know the life of the tube and how the bias is doing, and that there's nothing crazy going on. And it's just kind of cool having a meter on the top of it. And I got these caps installed. I don't think they were in here the last time. As you can see, we're getting close to having this thing finished. And these green wires came from the pin 10, which is the plate. They come over to the plates of the output tubes, and that puts the voltage on them. The other thing too is with the tubes installed and the filaments drawing current, we got 7 volts DC on our rectifiers, which is giving us 2 volts of headroom on the regulator, and they need at least 1.5 volts. So that should make the regulators pretty happy that they're only having to bleed off a couple of volts of headroom. And we've got exactly 5 volts on the heaters, which is not going to vary with the line voltage. And even if the voltage is a little lower and drops down to 6.5 volts here, we're still going to have plenty of headroom for those regulators. And so I'm real happy with the way this voltage, I think it's actually like 7.2 volts or something like that, but it's not a lot of DC for the regulators to have to deal with. I've seen some regulated DC 300B amps that have 12 or 13 volts going into the regulators and have to run giant heat sinks. That Art Audio amp we looked at was like that. It had almost 13 volts of DC go into the 5 volt regulator, which, they had to put massive heat sinks on them for them to dissipate all that voltage, and I don't really see why you would want to do that. So I'm real happy with this ISO transformer, and I've talked about this in the past. I've had really bad luck with EdCore power transformers, and I just cannot recommend them. Anyway, just got to put this cap in the front end, and then I'm actually going to be ready to, going to run the power wires up to the front end as well, and they're going to come from back here. And again, each channel has its own rail on the power supply, and so this B plus terminal is going to run to here, and then this B plus terminal is going to run to there. And then I should be ready to, I'm going to put the LEDs in, and then I should be ready to power it up again and check all my voltages on the front end tubes. And if all that looks good, then we got these, you can't really see them, they're kind of off camera here, but there's a couple of RCA jacks here in the back, and we need to wire those up to the volume pot that's going to sit right there, and then run those over to the front end tubes. Got to wire up all the speaker jacks back here. We're going to be using the heavier gauge AST pure silver wire for the speaker jacks as well. All this wire is silver plated that was military spec stuff, which I got a whole bunch of, and it's really nice wire. Don't feel like that needs to have silver wire in every location. Again, we've got these wires up here on the signal path. Those are silver, and we're going to have silver back here going to the speaker jacks. And so, anyway, it seemed like a good combination between the copper and silver that gives it a nice sound. So anyway, it looks like a great place to wrap up this video. So again, thanks to all you folks that subscribe to the channel, Patreon supporters, people that are members of the channel, people who made donations when they find the videos helpful to the projects that they're working on, people that have bought my gear, that sort of thing, and help to support the channel. I appreciate all you guys, and again, just for watching the video. Thanks again, and until the next one, have a nice day.